So let's start with the live session. We're gonna do opening Avizo software. You come to this screen. Just let me know if you have any difficulty in loading Avizo software, so we can explain a bit and how we can go around with all these functions. So if everyone already have this, I have to switch back to the screen that you will see the software. Okay, so here comes the interface of Avizo software. Can you open the software and you can see something like this? Okay. Once you have software open, the first interface you will see here is start page on the start, and you can see that next to each other there will be a workroom. So if you click on the project workroom or segmentation workroom and so on. So at start page, you will see that we have recent data, open projects, and create new project. What you need to do, need to open a new data, or you can create a new project. It's up to you. Usually when you use this for the first time, you will not see any file in this project or in recent data because you don't have anything yet. But once you create the project or you already open some data, the latest data that you have opened will be appear here. And you can also check here to don't have this start page all the time. So if you don't want to see the start page every time you start Avizo, you can just check on this button here, and then you can go directly to the project workroom. So let me tell you how we could start to open the data or load the data inside of Avizo software. So the easiest way, you can at the start page here, and you can click open data. And once you click open, they will automatically link to this data folder inside the install version of Avizo. So you can see it in data, and we look for the folder called tutorials. This one, double click on it and scroll down. You should see the first file here, not the folder, called chocolatebar.am or just chocolate bar, just the first file, chocolate bar. So just select and click open. And by default, I think you already have auto slide attached to this data, like I'm doing right now. So you can change this default by going to edit and then preferences. And here go to auto display. In auto display, you can select to automatically display the new data, and you can select different type of display or visualization module attached to your data. In my case, because I've been using a lot of Avizo, and every time I load the data, I don't want them to automatically attach the auto slide or volume rendering to my data. So I uncheck them because for me, it's a bit annoying to have auto slide attached every time. But for you, it's just up to you if you would like to have them automatically linked for you, or you can just leave it off and then click OK. You can also do the same thing in terms of the automatic display. You can see the button here on the project view. You can click to activate or inactivate the automatic display. So that's one thing that you can do the open. I will do one more time. If you want to delete something, you can just click and drag them to this trash bin to delete it. Or you can just select, for example, I select chocolate bar and I press delete button on the keyboard. It will delete. Okay, I go back one more time to repeat. I go to start and then open data to open the chocolate bar. And once you open the chocolate bar, you can see that in the recent data folder here, you see that the recent open one in the chocolate bar, you can easily click here and then they will open again. Because of I have this automatic display linked, so it already attached the visualization module. And if I click one more time, just to delete them, just to not link them, so I can drag around these two modules and press delete button to remove this. Okay, I just want to do one more time. Instead of open data, you can go to file and also do the same thing, open data, and then you just select again chocolate bar just to open it. That's the second option, and this time there's no automatic link to the open display because I uncheck here. So now I will show you the last one. So usually I said that you can start from the start menu. but you can also directly go to project workroom. This is where we're going to work mostly. So if you're already familiar with Avizo, you can directly click on the project workroom here. When you are on a project workroom, so let me explain a bit on the interface. So we have three parts. The top left here is called project view. You can see that where we're going to load the data and we're going to work on creating a workflow on this project view over here. Below project view is property, that it will show properties of each module, because Avizo is based on modular of visual programming. So all the algorithm that we created, we make it as a module, and each module, they have different details. For example, we have green color coding for data. And if you have yellow or orange, mean visualization module. And then when you do computing, we can activate red or blue or purple module that are more computing module. You can see later in the training. And on the right here, we have 3D viewer. So we can do visualization of the 3D. Okay, let's start that. Usually you can also open data here as well, quite quick. You can click on the project view and select open data. And now again, go to the folder data, tutorials, and select chocolate bar. So I hope you get familiar with this, how you can open different way the file in Avizo. So either one that convenient for you to just use it. So once you open the chocolate bar, hold on, yes. Can you, I cannot hear you. Sure, definitely. So if you have any question, just disrupt me in any time. Yeah. It depends on the unit that you are setting at the beginning. So when you load the new data that they don't know the unit, or if they don't have the metadata, they will select it as, for example, here when you click on the data, before you click it, it's not highlighted. When you click on it, it will be highlighted in green, and you can see all information like voxel size and physical size and the voxel information and the unit as well. So you can manage this by going to edit and select preferences, and you can go to units here, and you can select spatial information only, and then you can just select which unit you would like to use. Micrometer, nanometer, it depends on, usually if you have the metadata embedded in your data set, it automatically detected, so you don't have to do anything. But sometimes they will ask you with dialog pop up that this unit and the voxel size is like this, are you accept it or you want to change it? And here, one thing you could do with the units that, because we have two units, so one is display unit and another one is working unit. Usually, best way is to lock this display unit on the working unit. Then you don't need to be confused. But sometimes you want to visualize them as well. If you unlock it, for example, I show you right now, unlock display unit on working unit. And I have this automatic display unit, automatic determining working unit checked. And then I have nanometer as the selection. Click OK. And you can see here, I have the unit here that you can change. Because, for example, during the working, you cannot change the working unit, but you can change display unit. So it's two different ways. But that gets confusing because sometimes your working unit it fixed. For example, you have in micrometer, your working unit will be in micrometer, but you can change to anything you want. You can change to nanometer like this. And once you calculate it, everything is on display will be on nanometer, but your actual calculation is micrometer. So just that's why to avoid confusion, you can just go back to edit preferences in unit tab here. Just select lock display unit on working unit. And for example, I change here to micrometer that I want to use the micrometer, and then click OK. So then I should open this again. Go to start, open chocolate bar. Then I should have this in micrometers. I'm not sure why they're still showing in meters. That I can go back and discard and restart it one more time. But usually before you open any data, it's best to set the unit before you start working on the data set. So to have it correct. Sorry for this restarting. And again, if you have any question in between, just don't hesitate to ask. I'm happy to answer. Sure. Yes. Yeah. Mm. Yeah. Yeah. So we're gonna do it right away. So when I do this, so first thing I said before that go to edit and preferences and go to unit, and then I select to lock display unit and automatic determine working unit. So and I use micrometers. So okay, that should be right now. And then I start to open data again to the same one. And this actually the chocolate bar we open right here. It's from CT scan as well. So I open them, and now okay, I'm really struggling with this display unit, but okay, I'll get back to this to you again later. Anyway, yeah. So to adjust the voxel size, you have to activate the image. For example, I load them. It's not activated yet. It's not solid green, but when you click on it, it's activated. You can see the properties, and in this property port here, you can see the two over here. So the left one, this is crop editor. In this crop editor, you can crop, and you can also change your voxel size as well. So if you want to change to something else, you can also adjust the voxel size. You can also create your bounding box here by changing this figure, or you can just use this bounding box over here to drag around. Okay, that's the easiest way to change your voxel size. And we will go to this information later. So right now we just try to focus on this data. As I mentioned, so when I load the data the first time, you don't see anything because it is not activated. And you can see that I load the chocolate bar, it's still hollow green. Green means it's just data, so it's nothing you can do with the module, but it's just the data set. So if you click on it, that means it activate. And when you activate, you will have the information on property port over here. And if you look at the property port, we have information of the pixel size. So we have X, Y, and Z. So it's uniform coordinates. We have X 235 and Y 175 and Z at 295. And we grayscale 16-bit. You can already see that it's a lot of the intensity. So the window is mean where they start to see between background. And if you look at the thumbnail here, the background is black, and the window is like we start from pixel intensity is 0, and the maximum of the pixel intensity is 1910. That's the min max, and the window is just to differentiate between the background and the intensity of the image. So maybe I come back on this quickly after we attach visualization module, and you can see the memory size. The physical size is depend on the voxel size times by the number of pixels. For example, you times this 235 by this 112 micrometer, you will get this value of the physical size. And this is a preview thumbnail of your data. So it's grayscale. You can see that quickly it's a chocolate, it's 3 phases. So background and bright of chocolate and the feeling. And you can see the histogram and this dynamic range of the histogram of the grayscale. You can see they have 3 peaks. So most of the intensity distribution in the very background, the black one, and in the middle or the medium gray. And the third one is more like the brighter intensity. Okay. So like I said, the first thing we need to do, we need to visualize them and introduce the first visualization is 2D visualization. To activate any module attached to your data, just right click on it. Sure, of course. Actually, no, but it depends on your computer as well. So by rule of thumb, we need the RAM memory to process and visualize data, and mostly also with the GPU memory as well. So we say that we need at least 4 GB of RAM memory to display 1 GB of data set. So if you have 1 GB data set, you need at least 4 GB RAM memory to be able to visualize them. But we always say the more the better. So for me, I have 64 GB RAM memory, so I can comfortably visualize this kind of data set. But if you have really large data, maybe 10 GB, so you need maybe 256 GB of RAM to really work on it efficiently. So, and also you need a really fast GPU, fast CPU, and also like high-end graphic card. from NVIDIA. For example, if I show you my configuration, you can go to help and look at the system information. And in this CPU, I have Intel's Xeon. It's about 3.5 gigahertz. But then look at the OpenGL. So I need at least a really decent GPU, the graphic card. So I have RTX 5000. Yeah, and then it's about 4 or 8 gigabyte of the GPU memory. But this is something very usual that you need to keep in mind when you work it. Avizo that it depends on how large your data set that you normally work with. Okay, and one thing to mention is that I see that many of you using now Mac. Yeah, because we stopped support Mac a couple years ago already because we cannot keep up with the platform that keep updating all the time. So if you use Mac, some of the functions will not be able to activate it, and some visualization might be some problem. For example, we have the new module called the image recipe designer. It might not work on Mac for some recipe batch processing. So most of the function, if you don't see or it doesn't work because you use Mac, that's the reason. So mostly we continue working only on Windows. And it's really important to use mouse because later you see that a lot of tasks you need middle mouse click to visualize to do some activation of your data. Okay, let's continue. Here I open the data, chocolate bar. I already see some properties down here with a thumbnail. So next I would like to visualize them. So to visualize them, you have to right click on it. And once you right click, you will see on the left, you have the favorite folder. And bottom of this favorite folder, you have different kind of folder. And you have also favorite list. Before we go to favorite, we just maybe because I know that I'm going to do the display. So I go to display folder, click on display folder, and you can browse down on the list here. You can see that first I would like to try to do 2D visualization with auto slide. If you click on auto slide once, you can see that you can select them as to add on the favorite list by click here. It's already on the favorite, so you can click one to add or delete it from the favorite list. So just add it auto slide to favorite list and then click create. This is how you can activate and browse to the module. That's one thing you can do. Now I do by click on the auto slide and delete. So again, right click. Instead of going to display and look for the module that you're looking for, you can also look on this favorite list here because auto slide 2D visualization already in this favorite list. So you just double click on it. It also automatically attached. And the easiest way to find it, again, you right click on it and we have this module browser on the top right here, this way. So if you, for example, type auto slide or just auto like this, you can see that if you type only auto, then you have auto view, auto slice, and image auto projection. So you can select one of them. Or if you type auto and then slide, then just only one module available, and then you just double click on it. And then this auto slide will be attached to your data set. And last one, so I did it one more time. You see when you not activated the data, it's nothing on top here. But when you click on each data, if you have more than one data open, for example, if you have 2 or 3 data, you click on the data that you are interested. And when you click on it, there will be available the module that could be attached to the data set, the module that you used from the last time, the previously used. So you can see that I used some deep learning prediction, deep learning training on this data before an arithmetic module. And as you can see that I can easily select on it, click on auto slide, and it already attached to the data. And just to explain a bit on the color code, as you can see, I click on the data and they have available module to attach to my data. And green, color code green, is just the data set, the grayscale original image that you attach. And then this orange here is visualization. Its visualization could be orange or yellow. Orange is 2D visualization. And then if you attach the yellow module, it's going to be 3D visualization. And you can see it later, it's going to be red and blue or purple for processing module, computing module. Okay, now let's start with if you click on the auto slide, here you can see at the property part of auto slide, we always have the visualization box. You can toggle on and off like this. You can also toggle on and off of the each individual module. So if I toggle the blue box here, the same thing, or even on the master, on the dataset itself, and toggle on and off. And if in each module, you will see, for example, I go to auto slide here, and one more time here, auto slide here. So yes, a bit of. So I delete and attach one more time. When you select on auto slide and it activated, and you can, let's say, activate it on and off. And apart from that, we have this little white box here in front of the visualization module. This is the data port. So if you click on it, you can see that they have two options. You can select data to attach, and you can select column map. It's the same thing as we see here if you look at the property port. So start from data. You can see that you can attach auto slide to any data. So far, we open only chocolate bar data. So we have only one list of data be available. You can just select it here. And if you select no source, that means you detach the string from the data. You can again do the same thing by select from the drop-down menu and select chocolate bar to attach your auto slide to your data. And you can see this string here. You can always pull. If I pull the string out like this, use the mouse, just click on it, and then it's equal to that you have no source. And if you want to attach the auto slide to the data again, instead of looking for the drop-down menu here, because sometimes when you load your project, you start to work on it and you have so many data open and you don't know which one you want to attach because it's difficult to look on a drop-down menu. The easiest way is go to this little white box here, and you can see that you stick data, and you just have to create a string, and then you just place the string on the data you want to visualize. So later, if I open, maybe, okay, I do it right now. I go to start and I open again the chocolate bar. Now I have two chocolate bars, open 1 and 2. And then I have only one visualization auto slide. So you can just click on little white box here and select data to create a string. And you can place a string on any of the data, but it's two identical data, so it doesn't make any difference. But just to show you, you can always click, pull, and switch between different data sets, like, and so on to switch. Okay? Yes. Yeah. Yes. Mm-hmm. Yeah. Yeah. Yes, definitely. So what you can do here, you just right click, you activate the module called resample. So you select resample, and in this resample, you can select a different image that you okay. Another one thing, but sometimes you click and you can dock your panel anywhere, anytime, and sometimes you close it by mistake. So to do back to the default window, so you go to window and click restore default layout. Okay. Again, if you, for example, you can change it here, here, or you can just move the whole panel somewhere, and or you close it. Yeah. If you cannot find it anymore, just go to window and restore default layout. And what I did now, so I want to show you how you can resample the image. So I attach right click chocolate bar and select resample. And once you activate the resample module, you can see that you can select the output by select, for example, voxel size. And then you can resample them. Or instead of resample, you can do as well convert image type. So convert. And you can see that it's very flexible. You can activate any module that's available. And then if you apply some convert, they will show you what computing module that can attach to this type of data. So convert image type. You select convert image type, and then you can select the output. So here is 16-bit unsigned. You can select to 8-bit to reduce it. And you are right. Sometimes you don't need to work on 32-bit because it's too much information, gonna be too large. So usually if you have 32 or 16-bit, I usually convert it first to, for example, to 8-bit grayscale. So you can do this as well. And then you get this from 16-bit 20 megabyte to 8-bit 11 megabytes. Yeah, but we stick with the 16 for a moment for original data. Okay, so now let's focus a bit on the auto slide. So this is a 2D visualization, and you can see on the list that you can also add or attach this to the data, or you can remove them, and you can create this string. And please remember the little white box here is really useful in the future, because every time you need to link to the reference box, or you want to do any kind of reference, there's always something here that you can find on the little white box in front of each module. So click on it. But now I just need to attach to the data set here and click on auto slide. So look at the property part of the auto slide. So we have orientation, slide number, mapping type, column map, and option adjust view. So just go one by one. So orientation, you have this X, Y, X, Z, and Y, Z. And this, you can change different orientation of your auto slides. So if I'm on X, Y, and come back to this slide number, you can use your mouse to slide through different slides. And mapping type, we have the column map and histogram. Histogram doesn't give much information, just stay with the column map. And in column map, you can see the dynamic range of the histogram. So you can adjust dynamic range, like adjust upper threshold and lower threshold. So what does it mean here? Yes. Yeah. Okay, sure. So go to window and restore default layout window, and then the last option here, restore default layout. So you come back to this view. Yeah. Okay. And then you get something like this, and you maximize them. And you can also like increase the size of your viewer as well. So it's quite flexible. Okay, now if you look at the color map, as I explained before, you can see that we have maximum and minimum intensity. So the minimum intensity is 0, maximum intensity 19110, but window it starts from 410. So what does it mean here? If you look on the auto slide properties, and you can see that this histogram here. So the maximum and the minimum is obviously is the maximum intensity possible. But what is window? So window is from 4110. That means the intensity that could be differentiated between background and the image. So here we want to visualize the chocolate bars, and everything that starts from 410 is not the background anymore. So this is the start of intensity that not considered as background. So everything else below the 410 is considered as background, even at the bubble. And when you adjust this upper or lower threshold, what does it mean? For example, if I adjust to 410 one more time, like this, any pixel intensity that have intensity lower than 4110 will be considered or transformed into 0. Before we have 0 like this, so you have intensity from 0 to 401. But if you adjust lower threshold, anything below the threshold value, like if I adjust to 500, every pixel that have intensity lower than 500 will be transformed into the black background. The same for the upper threshold. So if I lower the upper threshold to, let's say, 1000, like this, and you can see that everything else that have intensity above 1000 will be considered as maximum as they saturated at 1, so 0 or 1. So it depends on how you adjust the upper and lower threshold to have the optimized contrast. You can also use automatic optimization. So click on this edit here next to the color map, click on edit. And on the top, this adjust range 2, you can adjust to the data min max 0 to 19110. Or you can again edit, select adjust range to data histogram. So it's more optimization to see that they adjust from 0 to the max 1351, not the full range into 19110. And you can see the maximum of histogram range is over here. Or you can adjust range to data window. So there we start from 4110 to 19110. So it depends on how you would like to adjust automatically, or you can manually adjust it, your data to visualize them. And as you already see, you can also change color map. So here we have different type of color map. So far we have grayscale image, and then there are some color map that not fit with the grayscale. So from this here, from label.am, label binary, label, this will not be able to attach to the grayscale because I'll show you right now. It's not a grayscale image. Oh, it's not a label image. So we're gonna work on the label image later, but now we are on the grayscale. So we should use only the color map that are according to the grayscale input. So if you go back to grayscale, this one, or you can change to, let's say, physics, and you can see this physics color map. Like here, you can adjust the lower color map in the blue range or higher intensity in the red range. So you can adjust them according to what you like to see. You can see here on the intensity. Or you can change to temperature and change again the maximum, minimum intensity. Sometimes when you look at the dynamic range and your range become very, very small, like if you adjust it like here, and you can see that the range is pretty small and it's difficult to move anymore. What you can do is you can zoom to the range. So you can right click, and then you can zoom to this range, and you can see this range has been zoomed back to zoom into the range that you are focusing on. Or you can just right click again and then zoom to data min max. So they will just zoom to this histogram. Just in case sometimes you have really short dynamic range of the histogram, so you can just use this zoom to range as well. And you can also load more color map. You go to option and select load color map, and then you can see that they go to the folder that we store the color map. So you can choose different color map, like pastel, and it's corresponding to what type of data. So this is how you could create or load the new color map. Okay, for now on, I'll just stay with one color. I say wallet green and adjust this, adjust range to data histogram like this. So, okay. And we have this option to adjust lighting as well on binary view. So we will see later if you adjust lighting like this, when you move this, you can see different lighting. If not lighting, it's always bright. So since I'm talking about this function on the right here, let me explain this one by one. Usually by default, it's on this the interact tool, is the arrow tool here. So when you are on interact tool, this means you can move this slide the same way but when you use the slider bar here. So you can use this arrow tool or interact tool just to pick on each slide, and you can slide them up and down. And next one is hand tool or trackball. So if you switch from arrow to trackball, then you cannot interact with them, but you can move them around using this trackball here, for example. And there has a shortcut on the escape key, ESC, to switch between these two. You can see that between these two, you can press escape key on the keyboard. So you can switch between hand tool and interact to between trackball and interact. Why? Because sometimes you need to, for example, when you want to do the image registration. So you want to move them, and then you want to turn them, move them, and turn them like this. So it's easier to press this escape key to switch between these two modules. Otherwise, you have to go to all the image all the time. But as you like, so if you feel more comfortable to click each time like this, click, move, and then click, that's also possible. But easiest to use this shortcut escape to do this moving and then change between the two. And then we have this translation tool. So this one, translate. So if you use this translate tool, or you can just click on the middle mouse, click and hold, then you can translate them. For example, I click and use this one, you can translate them anywhere. Or you can just use the hand tool here and you click the middle mouse again, button, and then you can just translate them. The same for zoom. So you can click on zoom and zoom in using middle mouse view to zoom in, zoom out, but it's really slow. You can do by using a shortcut. You press left and middle mouse view together, left click and middle mouse view, and then now you can zoom in, zoom out very quickly. Is it working? That's why we need a mouse for this training, because it's really useful to use mouse. And then we have this step rotation. This could be used for example, you want to create a really steady animation of turning or rotating object. And then look at this seek tool. So maybe let's show it like here first and go to some slide. Okay, so to use this seek tool, so you press on this one. You have to be on the hand tool first, and then select the seek. So if you hover the seek tool on any point, they will zoom in at that point and focus this at the center. So they will recenter. For example, I focus on this one here, and you seek tool and you press one, they will zoom in to that point and recenter them to the center. The same here, if I want to again do seek, press on the seek tool here and focus on this one. Yes, and then we'll zoom in to that point. They also used could be nice for using in an animation. Okay, and then this home button, if you click, they will come back to the home position. And you can also set home position as well. Like you click this one, whatever you want to, you just rotate them and then you click to set home. And then after that, when you change, and then you can come back to home position. And here is a bit obvious, but also some could be confusing on the auto slide. So we have the camera projection. So we have camera projection in XY, camera projection in XZ, and camera projection in YZ. And this one is the view or global view. For example, if I remove this, move it somewhere, like by accident I press it, or I maybe zoom out too much, I cannot see it anymore. You can just press this view or button or space bar. It will come back to the last full view. For example, again, I do like here, or move it somewhere here, and then you cannot see it. Sometimes when you open a different data set, you open data with have really large voxel size, and you open the second data that have very small data set size. So you will not see the second data set because it's been hidden by the large voxel size. So what you could do, you focus on one of the data set size, like this one, and you press spacebar or this view or button here. It will come back to the view that you can find it easily. And for example, now just a bit more detail on the camera projection. So if I here on auto slide bar and I set orientation to XY, but if I want to, if you have the chocolate bar like this in XY projection, then if you select this camera projection in XZ or XY, they will go turn the other way and then project them. So I'll show you right now, like here, you can see that even the auto slide is set to XY, but when you select this XZ projection, they just like you turn the camera in the other way, you can see like this. And why I mentioned this, because if you go back to auto slide and change the orientation to XZ like this, and when you select XY projection, you can see that it's kind of from XZ position of auto slide, but then you project camera in different way. So you will see this. So that could be confusing at the beginning. Anyway. And this one, the last one, is the perspective view. If you click one, they will cycling between orthographic view and perspective view. And this is really important for later when we do volume edit or some kind of visualization editing. So what the difference, if you look on to this orthographic view and perspective view in 2D, it's not much different. But if I add a bounding box quickly to show you here, and I can see that when I turn a bit, start to see bounding box in orthographic view or perspective view. Sorry, we have this by default is perspective view. By for viewing, it's nice because you can see the dimension is different. On the back is smaller than the front, but actually if you do on the orthographic view, actually it should be all overlap on each other like this. And why it's important? Because when you want to, for example, cut the object with some certain tool like circle tool, you want to cut project of the cutting tool deep into this camera here. But then sometimes when you use perspective view, because it's projecting like this, so you're not sure if your total volume or your circle will cover all the area of the chocolate bar or your object or not. But I will show you later in the real example. So not too much. And then we have this stereography, so we don't use it, and we so use the peak tool. So you want to see like which one is activating, so you can use this one, but it's not really useful. And another one is also quite useful tool is this one, measure. So to do this, I just change color map from from green to grayscale. Oh, wrong one. Grayscale, this one. And I tap to here. So if you want to measure something, we have this standard measure tool briefly. So you want to measure line, click on line, and just like want to measure the line between this, and then this unit will be calculating according to your setting. So it's about 200 micrometers, and you can also pardon? Sure, no problem. So what you could do is you just go to this tool here with the ruler. You can see this, and you click on the drop down menu. You can see line, angle, annotation, box, and circle. So I was clicking on line, and then you have this icon coming up. For example, I want to measure the distance between this and this, and you can see this line measurement with some annotation of the unit. You can do again, click, for example, angle. So I want to maybe measure the angle over here. I know it doesn't make sense, but you can see this angle has been measured, or maybe again, every time you need to click on this object and then, okay, angle. And then here and here, you can see the angle. Maybe one more circle. For example, if you want to draw the circle and measure diameter, they will give you this information, cycle of diameter of this unit. Yeah, because I think at the beginning when you go to edit and preferences and add unit, just select special information only, because maybe it's on none, then you don't have any unit coming up. So just select special information only and just select automatically determine working units. Yeah. Yeah. And now I know why I have this display unit in meter. Here, just I was try to find out, and then I forgot that, because when I set on the unit here, they have this display unit and working unit, and before I locked it, I didn't change the working unit yet, so it was in default by meter. So to do that, I need to unlock first, uncheck at lock display unit on working unit, and then go to working unit, and you can change. Yeah, use micrometer. And also uncheck automatically determine the working unit as well. Sorry, that's one little things. So once you change it, you should be able to change to any parameter. So I maybe change to micrometers and click apply. And then again in display unit, I change to micrometers. And yeah, I still don't understand why this doesn't work with me. The measurement, yes. For example, you can see that I delete first. You just go to this button here, the tool here. So you click any one of them. If I click, for example, even annotation, this yellow measurement will appear automatically. So it's deactivate the module. So, and you can always delete it or activate it again. So if I delete them, you can go here to the, for example, line, and then you can click, and then everything is in measurement tool here. You can also go to measurement and then select different things, like to add the angle measurement to create the annotation here, and a cycle line, and then you can just add to your measurement here one by one. So, but it's just only rough estimation. Is based on also unit setting as well. Next one is the probing tool. So you can see that we have continuous update and click for update. So this one is really interesting, because if you select click for update, so you have to press shift and click to update information of your sampling. So what I will do now, just zoom in a little bit here, like this. And you can see I zoom until I see kind of pixelated of my images. And then change to this interact tool or arrow tool before you do picking, or probe tool here, sorry, probe. So then I will check, click for update. Now I want to probe different intensity in different pixels. So if I go to very dark here and I shift and click, you can see that the showing the value at the bottom 174. So this is the intensity of that pixel that I probe. So I go next to it, I go to shift and click, and you can see the value of intensity change to 235. So it is in a dark area. As you remember, the set window is about 410. So this pixel that I just probed it before is 200, 300. So it's lower than the window. That means it's considered as a background. And then if I go again to this very bright area here, so I go to probe tool and click for update shift. So I press shift and click, and you can see now the value is about 1,340. So that means that you can see that you work on 16-bit and the value could go up to 60,000 value of change of intensity. And this is how you probe the individual pixel intensity. And later when we create the binary image, you can also probe like which material ID is it. But at least just to understand quickly like how this probing doing, you just want to examine individual layer intensity or pixel, that what is number. So if I change to continuous update, you will see the value here when I hover to different shade of the intensity of each pixel. You can see in the lower grayscale or higher, it brighter is higher. So it's according to the histogram of the images of this grayscale image. Okay, and then we have this snapshot tool. So I go back to this space bar here. So we can create very nice snapshot in one click. So you click snapshot, and then you need to adjust the parameter. Yeah. I'm not sure why this always keep this pickup, even in the snapshot. Just hold with me for a moment. And then after the snapshot, we have one viewer, two viewer, and four viewer. So you can select to activate your viewer to Windows, three viewer, or four viewer as well. Okay, now the snapshot coming up. So when I press one at the snapshot two, you will see that snapshot. You can copy the snapshot to file, or you can print them, or you can copy to clipboard to paste them somewhere. If you want to copy to file, you have to specify your file name output. Where is it? And then the quality of snapshot is not depend on your screen. It will depend on the render tiles that you will set here. By default, it's 1 by 1 tiles. So the resolution is very low, but if you change to, for example, 20 times 20, then you will get very high resolution. You can even do like a poster printing from this snapshot. But if you snap very high resolution, it's gonna take a little while to capture everything. But at least you know it's very easy to cap. So you will get what you see, and the resolution is not depend on your screen. Resolution is depend on how you would set the tile rendering. And now you can see that we have two viewer, top, bottom, side by side, and four viewer like this as well. And we will come to this in a moment. So with one viewer, you can see that you can add more than one auto slice. So if you click on the chocolate bar, and you can see auto slice being recently used, so you can click one more time and again click the third time. So you have 3 auto slice. But now every slide have almost the same position. So you have to, for example, when we change orientation from XY to XZ, and the third auto slide change to YZ like this. And now you have 3 auto slides. So you can change them using this interactive tool. So pick on them and move it around. You can also change each color map of the auto slide. So for example, to physics, this one to green, and this one to, let's say, hot temperature. So now you can see different cross section in X, Y, and Z plane, and you can also interact them between this. Check here. Okay. So next thing I would like to do that how you can, for example, we want to visualize 2 panel together at the same time, and also to split the window. So what we do, we're gonna use auto slice. So we attach a slide 1 and one more time, 2 like this. And to have them visualize in 2 viewer, let's go to the next 2 viewer option here. Click and you have 2 options. And you can see that the first viewer and the second viewer, they have the same slide number 147, 147. So now I would like to link camera projection. For example, you're on the left auto slide 1 on the left, and auto slide 2 on the right. Before we link the camera projection between two slides, we need to define which auto slide to show on left and which auto slide to show on the right to avoid confusion. So I will go to auto slide 2 and change color map to, let's say, physics. And you can see that when I change auto slide 2, it's still showing on both windows. So as you notice it, when you activate the two viewer, like when you are at one viewer, you have only one window. When you click on this two viewer, then this display viewer toggle window here will be split into two. So now I want to select auto slide 2 on the right, so I inactivate the left one, and the same for the auto slide 1, I inactivate the right here. So now I have two auto slide identically in the same position. So now I want to link them together. So right click and preferences, and then select right click and then go to link camera 2. So I was on the left with the grayscale image. So right click and select link camera 2, and you can see the camera icon appear here. And then you just move this camera icon to link to the right one, like this. Okay, and now if you do this moving, then we just link everything that you do the same. Okay. And what you can do now, you can go to XY position, or you can go to this. Now, if you would like to link how you gonna change orientation and the slide number using this port here, you can do that by using connection editor. So if you browse on the auto slide 1 and just see on the auto slide 1 property port, you can see this chain icon here. This chain is a connection editor. By connecting them, you click once, you will see this kind of open chain sign appear in front of each port. Okay, again, you just select one, let's say the top auto slide 1, and select this chain connection editor, click one, you have this connection port like open chain. So first I want to link the orientation of auto slide 1 to auto slide 2. To do that, you have to click on the orientation port chain here, click once and hold, and then drag it to the auto slide 2. When you go close to auto slide 2, you can see this, it turned to plus sign. And with I release mouse, they will have the string. And now this orientation is being linked, as you can see here. I will do the same for slide number as well. So in auto slide 1 on the top one or the grayscale here, left click and hold on this link, the chain link here, click and hold and drag to auto slide 2 until it appears as a plus sign. Now I have two port links, is orientation and slide number. So for example, if I move this slide number like this, it will go synchronously. The same with the orientation. And you can also, because of link camera orientation, you can move them around. This you want to, for example, have two example, two data set. You want to compare them side by side. You can use this kind of link. Okay. And you can also just click on a single viewer to come back, or you can delete one of auto slide just to deactivate this link. If you look here on the chocolate bar, you can see they have the pin port. For example, I want to pin information like latitude info, so I click on this pin, so it pin in blue. And again, maybe let's say the box size, I pin it. So this port from chocolate bar will be pinned. And then if you move to chocolate bar like this, to auto slice, you can see the property of the chocolate bar still pinned on top of the auto slice. So you can see all information that you need. Sometimes you will need it. And if you look at each module or even the data, you will see this question mark over here. This will explain about what they are doing. For example, if I'm on the auto slice and you select the question mark icon here, they will pop up the help menu, how the module auto slide work, and what is the input and output port, what is the explanation for each port. Or you would like to get more information on the help, you can get to user guide. For example, you go to help and select user guide. In user guide, we have this introduction how to start using Avizo software and also extension. And the best one would be tutorials. So you click on tutorials, and if you are connected to internet, you can select at the YouTube Learning Center of the Avizo. You can also go to, for example, getting started, and then they're gonna explain to you what is interface and what I just explained to you before. Try to load data set, attach some visualization, and so on. This is can you consult it. You can also search for example, a tutorial, or you want to search for something. Let's say I want to do deep learning. So you can say, and then you can just have different things related to deep learning information here. Okay, so that's more about 2D visualization. The next one, we're gonna start doing 3D visualization. So I just click on auto slide, press delete button, and now we'll activate 3D visualization. So right click, and usually I will use some of the tool on the bottom here, on the volume rendering or Warren. So let's say I select first on Warren. Warren is the kind of prototype 3D visualization, so they don't need much resources. And maybe some of you cannot have volume rendering, the Warren would be alternative option. So in Warren, you can also adjust like dynamic range to see them in 3D volume like this. The more you adjust lower, upper dynamic range, you see the structure that what you like to see. For example, here I adjust according to the window 410. So that means everything that below 410 will be discarded as a background, and then I adjust the upper dynamic range so to see something like this. But if I increase the lower threshold, as you can see that the intermediate intensity inside of the filling of the chocolate will be new as well, based on what I filter them on the dynamic range. Okay. So apart from Warren, we usually introducing this visualization module called volume rendering. So you can select from the list here, volume rendering, or you can just type on the search for module, volume rendering here, and then double click. So you can get this by default, the very realistic display of your volume. And again, this is a chocolate bar scan from the CT. You can also unpin this property port of the chocolate by itself, and you can just only volume rendering. Again, if you adjust this chocolate bar color map intensity, dynamic range, upper and lower threshold, you can play around with. So if I adjust the full volume, actually it's like this when you scan everything. And then you lower the upper threshold and then increase the lower threshold to get it more here, or you can play around like this. Or even you can have the full volume and then change the opacity on this scale over here. So you have the more transparency of the chocolate bar of the opacity. And all this setting is on the bottom tab of the volume rendering. So we have volume rendering setting and volume rendering. So what we are looking at is just by default volume rendering on the bottom tab here to adjust dynamic range and the opacity. You can also change color map again to, let's say, physics. And now I adjust this city here. So we are at volume rendering, and I already show you that we can attach this bounding box. Right click and create a bounding box. And you can see this is the full volume of the chocolate bar. You can also change color map of the bounding box to other color, like green, like this. So you can see the bounding box of the chocolate bar look like this. Now, since we have these two 3D visualization module open, you can see that in yellow. Before it was auto slide in orange, that 2D. So I'll show you the next tool called clipping plane. So right click on the chocolate bar and attach clipping plane here. So you can see that because I set bounding box to green, so you can see that clipping plane in orange, or you can change to something like red as well, like this, to easier to see. And clipping plane is just like auto slide, so you can change orientation of your clipping plane as well. And you can also clip them by using this icon here to clip the object. So if you click once, it will clip in one direction, and you click one more time, it will come back to full volume, and you click again, it will cycling on the other side. So you can see that you can clip between left, right, and come back to full volume. So I clip in one direction here, and you can also still change your clipping direction, X, Y, or to Y, Z. And after clipping, you can still translate your clipping or change direction again and translate them. And here you can imagine that you can create nice animation of the rotating object with translation of this slide. So zoom in, zoom out. And as you can see here, when I do the clipping, everything that are activated in the 3D viewer will be clipped. Okay, I unclip one more time. And you can see before, bounding box and the chocolate bar itself been activated. When I clip them, everything has been clipped like this or like this. But if you inactivate the bounding box, for example, now only thing will be clipped is chocolate bar. So this is the principle of the clipping plane. So it only clip whatever activated in this viewer. So maybe I move the clipping plane like here in the middle, and then I clip them again one more time. So now you see the 3D volume is activated, it's been clipped, but bounding box is not activated. And now I can activate the bounding box. You can see the bounding box is still full volume. So in this sense, you can, for example, you create the two volume and you hide one volume and you create a clipping plane on the second volume and you merge them together. You have one that half clipping and the other one is full volume. So that's the principle of clipping plane. So it clips everything that I activated. You can also hide clipping plane by click this visualization here. You will not see clipping plane anymore. For example, even you hide it, but you can still rotate them or change the orientation. So you can see this in and out of the clipping plane. Okay. So if you don't want to use clipping plane, we also use the same tool from auto slice. So we go to add another another auto slice onto this volume. And you can see that on auto slide, we have a clipping function as well on the top right corner here. So you can see the two. You click one, clips. So the auto slide already clipped the volume. Change direction a little bit here. And the cool thing about auto slide when you overlay on top of this 3D volume is that you can, for example, change the transparency to binary like this. Once you change the transparency of auto slide to binary, you can adjust the lower dynamic range. So you can see object like this, or maybe a chain to the same physics color map, and you can hide frame, by click here to show or to hide frame of auto slide. So now you can use this auto slide as clipping and also show the same color. Or you can switch back to other color to make it more effect. So for example, I change to temperature and high frame with the binary dynamic range adjustment, and you can see something like this. So the combination between auto slide and volume rendering. So yeah, another thing as you can see here on top of project view, the window here we have project view, select mode, and hand tool. So it's the same like on a 3D viewer. So by default, it's on picking mode or interact mode. So you can individually select each of them. But if you by accident click on the hand tool, everything will. So it happens. So you know that you can switch between selecting individual module object, or you can just want to move everything at once to arrange your workflow. And okay, here, and you can see this, I already mentioned, this is auto display. If you select it, it will determine the visualization, mostly auto slide by default. And here you can switch between the project view and the kind of tree view. So if you switch be here, but this is more flexible because you can move everything anywhere. You can create your own workflow. This tree here is a bit, yeah, it's not very interactive. So just so you know that it's possible if you would like to. So this is more about the first session on visualization. You can see already we have bounding box. We have 2D visualization with auto slide. You can do 3D visualization with volume rendering or Warren clipping, and combination of the different modules, and also 2 viewers, 4 viewers, or something like this. Is there any question from this step? Sure. No. So usually in Avizo, most of the rendering they run on GPU, and we do the calculating like computing module on the memory, and sometimes also on the GPU as well. But also CPU will also help, because for example, you want to run deep learning, and even it run on the RAM memory, but also you need the core of the fast GPU as well, CPU as well, like 3.5 gigahertz, more than that. And then if you have really like old CPU with the low clock speed, then even you have a high RAM memory, then the computing is not going to be really fast. But yeah, to answer your question, it's not possible to switch. Yes, just the rule of thumb, but much more. So in general, I would recommend 128 gigabyte RAM if you can, and the more the better. If you have money, just invest on it. Okay, next we're gonna start doing image pre-processing. So okay, let's delete it and then start with chocolate bar. And if I look again on auto slide, by default is grayscale. And if you zoom in really quickly, like this, you can see that it's really noisy, really pixelated. What you could do is you could apply some filter to remove noise. So we have different type of filter. If you know or have some experience before, you can use, for example, I know that median filter is very quick for this. It's called salt and pepper noise, because it's very grainy. Again, if I zoom in quickly, so this kind of noise called salt and pepper. So if I just want to remove this noise, easily you can attach median filter. With median filter, so you can activate. Now the first time you see this computing module, so in red or pink, and in the property part of the median filter, you can just select if you want to interpret them at XY plane or 3D volume. You can also do a 3D. And with 3D, you will have this, how you would consider the neighbor of your median calculation. So if you don't understand exactly what neighborhood means, you can click on a question mark. They will explain what is neighborhood here, and then in terms of neighborhood, they will consider the surrounding neighbor of your voxel to be incalculated, because in 2D it's just only XY plane, you just count on top side only. But for 3D, it have 3 possibility. If you consider this voxel, so in 3D, 2D is pixel, 3D voxel. If you consider voxel as cube, so the lowest number possibility of the neighboring you can take into account is only the one that have face to face of each cube. And in the medium, you also consider the voxel that have the edge also attached to your center of the voxel. And the maximum will be anything that share edge, face, and also to the epicenter of the point on the voxel. That means if you have center voxel to consider in terms of apply this median formulation. So if you have option to select between 6, 18, and 26 of these neighboring voxel, that's why it's explained here. So usually we take into account of all possibly all the neighbor of the voxel in the center of voxel. So, and then you use iteration. So the more iteration you have more smooth effect on the object, and you click apply, and you will get the new results that you can just move the auto slide from original data to the second auto slide, or you can attach the second auto slide to the new data set and activate the 2 viewer, and again split the window that I want the right one like this. So now you can see the right one with the median filter effect. So it much smoother from what you can see on the left hand side original image. So that's some example if you already have some experience. But if you don't know anything before, what you could do is just, we have this tool called filter sandbox. So right click on the chocolate bar and type filter sandbox. So this filter sandbox, they will come with their own viewer, like auto slice and little blue sandbox here. So you can use this arrow tool to move your sandbox in any region or resize them like this. So I just move this around here and use the trackball to zoom in a bit using whole and middle mount together. So in filter sandbox, you can also again do like auto slide, adjust dynamic range to see better like this. And at the end of the property port, you see that filter. So you can select from the list of the filter that you can apply. So sometimes you can use it depends on type of data. You can try see the lateral filter, and you should see some effect immediately. Not much on the bilateral. So if I go to, for example, Gaussian, but Gaussian I don't recommend for using in image processing because it's just only blurring, but it doesn't preserve any information, so they just blur. So it's not very good one. The better one would be median, is because it's really fast and very efficient. As I mentioned at the beginning, now I do this. So window restore default layout. That we need also really high-end graphic card as well. So if you look at system information, so this is GPU that could be CUDA compatible. So that's why we need to show you here in filter sandbox. If I select other sophisticated filter called non-local means filter, select here, then you can see that they will use the adaptive GPU. So that means they need a CUDA compatibility with this C, and the CUDA device is in the NVIDIA RTX GPU that I have, and you can adjust its term of number. Non-local mean is the best filter that we have because they really remove all the noise and they have the preservation. So it's really good, but also takes some time to process them. So compared to median filter, because for example, this image is really easy. So you can easily use median filter and you get away with it. But some image you really need to do non-local mean filter to get a better shot, the better contrast. And after you apply non-local mean filter, you can also come back and apply again, for example, on unsharp masking. So you can combine different filter together. So usually, if you really need a good images with edge preservation and then smooth or the noise, so first you apply non-local mean filter, and after non-local mean filter, you come back and then do unsharp masking to really enhance your images. So two combination. But for the example, median filter, we do the good job. And later, if you're interested, we also have the deep learning. You can also use deep learning denoising model that we have as well to try on your data. And it's actually designed for EM data, so I'm not sure it's gonna work with the CT. If you work on EM and you need denoising deep learning model, just let you know. Okay, so as you can see that I select median filter, and if you change iteration, you can also see the effect of change on the fly. So 3 should be enough. And then you click apply. And then you just see that they have get the new data, copy here. If you want to change the name of this data set here, because this is the results actually, and this original data, you can press F2. Here you can rename them like, yeah, you can rename them to something else if you don't want to, like just change. So everything can be renamed, even the module, you can also F2 and rename them. Yeah. Because sometimes you have the experiment and your dataset type is really long, and later you want to look for your dataset from drop-down menu, maybe you could not find it because it's too long and then it's too much. Why you can easily like rename them to one result to something like this, so that you know exactly what you're looking for, like result 1. This is good thing about renaming, because I get this a lot from when you're creating workflow and you want to look for the exact which result that you're looking at. So it's to avoid confusing. So once you have this result, you click apply, and you can see that this filter sandbox still activated here. And if you attach auto slice to the results, you can see that you will not see the result because the slide of the filter sandbox still block the view of the auto slide. If you turn them loud like this, you can see that actually our auto slide is behind the filter sandbox. That's why you don't see it. It's also something you should keep in mind when you're working with Avizo, that if you don't use any window, just inactivate them like this. Or you can press Alt and H for hide. So you press Alt. For example, I want to show only the auto slide, not the other module. So you click on auto slide and press Alt and H to hide something else. Doesn't work for me. Otherwise, you can click H hide. Yeah, but usually it should work. So I feel a bit embarrassing with some tools that are doing right now. So you can see that because I hide filter sandbox, otherwise it will block my view. And this is the result from filter sandbox that can visualize in the smooth way. And why I'm doing this, so I'm going to show you right away. So in Avizo, we want to work on the global values of the pixel intensity. So if you zoom in, you can see even if you want to calculate the volume or area of this blue black dot here. So if you work on the grayscale image, you have to like work on if you have 16-bit possible like 60,000 value. So instead of doing it, we're gonna simplify them by create the label image or binary image. So we're gonna binaries them by define the threshold. As I showed you before, we have this probe tool here. So I have this continuous update here. You can see that the lower value is about 100 and the grayscale is more than 600, something like this. So you know that what threshold of the intensity on each region or each material you would like to get it from. So now what we're gonna do, I can go to the module for binarization. So we have different tools for binarization. Yes. Yeah. Or you can do non-local means filter. Yeah. Non-local means this one. Yeah. Yeah. Like so first you try non-local means. Yeah, you're gonna run for a while. After you get result from non-local mean, you can reapply. For example, here, if I use filter sandbox again on it, on this data, and then you can apply unsharp masking after you have non-local means. So this way you're gonna get better results. Something like this. This is still on. Sorry. Yeah. So this is so for example, if this supposedly to be a non-local mean, and then you reapply again, then unsharp masking on the non-local mean itself. So you get something like this. So maybe too much of the something like this. So yeah, we recommend that first apply non-local means and then followed by unsharp masking. That's the most recommended because they have the best effect on the images. But if you don't have very difficult data, not so much noise, you can just use a median filter. And if you have some, for example, ring artifact, you could use FFT, fast Fourier transform filter. Or if you have uneven background, you could use background detection correction. And you have some ring background, you can use bilateral filter. So it depends on the type of image and artifact that you have. So yeah. Yeah, just that's what I said. You can use this filter sandbox and you can try different filter and you can see by eyes already, but that which one is keep the smooth and still preserve the edge of your result. So for example, here it's CT scan and I use median filter and it's really quick, very fast, and it's really good. So we can try first with median filter and to see if it's still good enough. But usually median filter is do the job most of the time. Unless you have some difficult artifact, like ring artifact, 360-degree ring artifact, it's also difficult to remove. Or if you have to normalize the background using background detection correction, also could be some example. But in general, like median filter, we do the job. Yeah. So we talk about the binarization. So you could have different way of binarize them. You can use it's called global thresholding. That means you have fixed one value that you have everything according to your global. For example, here we have dynamic range from 0 to 144. You want to set the lower threshold at certain value and the upper threshold at certain value. Only the pixel intensity in this threshold will be selected. That's the global thresholding. But we also have like multi-thresholding and local thresholding, top hat thresholding. So it have different too. So I will show you the global thresholding called interactive thresholding. So the result from filter here, I attached the module called interactive thresholding. It's a really really useful thresholding tool. So it's global threshold. You can just set the lower intensity and the higher intensity. So for example, you want to threshold only the bright area. So you will move the lower threshold until you see only the bright area only, or even the brightest area, not even the medium grayscale. So this is how you threshold the object based on the intensity. You can see down, I have local threshold, the lower threshold at 900, something like this, and until maximum. But if you want to threshold the air bubbles, so it could be the other way around. So you have to select from 0 until you reach all these like 560, and now you can see the air bubbles inside the chocolate bar. But you also get the background. But we also have something else to correct this. And the reason that I do median filter, as you can see here, if I select on the higher threshold for the time being quickly, like this maybe, and you can see this, I can move the string of interactive thresholding to original data. It will look like this. And you can see that before median filter, it's really noisy, really pixelated. After you smooth them and you use the same module, the same value, you can see the most of noise has been corrected or been removed. That's why the filter is really important step before you do image segmentation. So we're going to do segmentation right now. The first step of image segmentation is to binarize them or threshold them. And before thresholding, it's always good to apply filter to smooth them or to remove the artifact noise and correct the background. Yes. Yes. Yes, we also have multi-thresholding that you can do more phases. And later you will see tomorrow with the segmentation workroom, you can segment a lot of materials, 100 of them. And we have the tool called watershed segmentation based on the binary mask that we created. We will see tomorrow. But yeah, exactly. So for watershed segmentation, you need at least 2 materials. So yeah. Yes. This one is automatically created. For example, yeah. Yes. Because I renamed them actually because I used it. Yeah. Yes. Yes, because when you click on the filter sandbox, click apply, they will generate this result. And this string it just show you the result is created by the filter sandbox. Yeah, I can take a look. Probably because you know what then maybe that gives it but then and then if you need a break then you are keeping that. We need some sensitivity as well. And then we can best if when we get usually everything will be on one explaining. Any questions?
We started segmentation. Could you explain a little bit more about the reprocessing of the images?
Yeah.
Like historization, normalization.
Yeah.
Show us the results.
Yeah, sure. Because usually when you have the grayscale, yeah, show you instantly and you see like how the pixel intensity in the unit for the image. And yeah, so well, it is the 16-bit for the intensity range to be from 0 up to 9, but you have 8 bit, then it comes to 20. And then when you are using a data, you're gonna select only certain pixels that have certain so threshold limit right bank, and you know that in right on your feed, in probably online that you will make then you get that we get the right value. If you that you will get that one out. So on
Yeah, but everybody is processing the image.
yeah. Oh yeah, just to continue to you can see that the variety of the images they always have certain different language.
So in which case I want to do historization, for example.
Yeah.
Or historization. Where you want to do it.
No, don't have to do memorization. You can already do it outside the computer. That's average by you can be because of the calculation of the sleep negative to balance them. And just for this library, it's better. We want to just to make it more easier to group them. Here. But usually we do every time before we do any segmentation for image processing, we need to apply some filter to give them a better images quality before. Yeah. So for example, here it's filter to enhance the data quality. So you can see that before we apply filter, they have so much contrast between different pixels. So we can apply different filter, and this explanation is here. So we have this box filter. So you can see that if you consider the center pixel or voxel have the neighboring value of 5, 3, 4, 5, 5, 5, and then the center is one is 10. You see much contrast. So you apply the box algorithm, and then you can see that they reassign the new value to the center voxel, become 5. So it's more homogeneous with the neighboring. The same for median filter. You can see here they use the mean statistical calculations. You can see instead of using the native value, so you do one by one. So the center voxel from 10, they average to 4, and you can see the smoothing. In this way, you can see that on the left, there's so much contrast. That's called noise because it's bright, dark here. But then when you average them, it's kind of homogeneous and there's not much noise anymore. This is how you remove noise or to kind of blurring the background. And here is non-local mean filter. So instead of simple mean algorithm, but it's not local. So they not really based on the neighboring voxel. So they use this non-local mean to get better. As you can see on the left, it's very pixelated, very noisy, very like Lego thing. But when you apply the filter, it's smoothing. And then when you select the threshold, it's gonna be easier to, for example, here you want to get only the middle black dot without some, because if you don't filter, you might get this as a black dot because the signal is too strong, but it's just noise. Yeah, so I will upload this presentation to the server as well, so don't worry that I will get this. And here like filter canals, so in 3D, yeah, you can see that is some example of the filtering. So you can input here, and you apply Gaussian and median, it look the same, but actually median is do much better job because Gaussian is just blurring, but it doesn't really preserve information. Median is always recommended, not the Gaussian. And yeah, so we have also like here, remember that we use the non-local field. Yeah, if you have this image only, and if you use unsharp masking, you get this image, but still really noisy. But if you apply first non-local means and followed by unsharp masking, you get much cleaner image, less noise. That the idea here is just to remove noise before you do segmentation. Okay, now we are here that I want to, let's say I want to segment the porosity, the bubbles. So just start from 0 and go to, let's say 600 value of the intensity here. And you can see that if I select this, I get this quite nice, only the bubbles. But if you don't do filtering, if I don't do mean filter, you can here, you can see you get a lot of dots coming up. That's what I don't want, because I only want to have like a major porosity inside the chocolate bar. But if you don't do this, apply any filter before, you get a lot of noise, little dots everywhere. So that's why filter is really important. Is that clear from the example? Yeah. So the reason I just hold the threshold the bubble like this, because I want to get the air bubbles in the chocolate. And this I will apply another module that I will show you next. So you can also select to see the preview of your threshold by 2D or 3D. So or both. So here now I have both visualization of 2D and 3D. But because I threshold also background, you don't see anything unless you change the intensity of the lower threshold to higher threshold. So we see this example of 3D thresholding, and I threshold more, so I get something like this. Again, if I go back to the first data without filter, you can see when you threshold them, you get a lot of noisy pixel coming up as well, like this. Yeah, but I think 3D thresholding sometimes could be the best to examine everything. But not in this case, you want to do this air bubble because it already blocked by all the background. So I just do it like here around 600 like this. Okay, once you are happy with the thresholding intensity here, just click apply, and then you will get the results. And you can visualize the result with using auto slide or volume rendering. So with auto slide, you will see this is the binary mask of the intensity we need. If you look at the volume rendering, right click and select volume, or voxelite rendering, the same thing. And then you will get 3D volume. Again, you don't see anything unless you click this clipping here, and you can see that actually we threshold the background and this thing. Also, one interesting thing about auto slide, what you could do, you go to result one or first, doesn't matter which one, you just add auto slide to the original data. For example, if you right click on auto slide, you will see this color watch module to attach to the auto slide. So click on color watch once, and now you have color watch as the 3D module attached to the auto slide 2D. And in front of the color watch, you have the little white box here. Click on it once and select the data. When you select data, you get the string, and you can put this string on the label image or the binary image. Then you can overlay them, okay, data, and on top this, you can see like this. You can see that you can change the color map of the color watch from 8 color to 256 color like this, and you can adjust also transparency of the color map. So here you can browse to how you threshold, but it's exactly the same what you see in the interactive thresholding module. Maybe a bit explaining on the result from interactive thresholding. If you look at original data, it grayscale 16-bit, and the possible value of pixel intensity is up to 1010, and you can see there's a lot of information. But when you convert them to binary image, we call label image here. So this one, you can see that before is the preview, is the grayscale preview. But you click on the result, you have only so-called label. So background is 0 and light blue is 1. You can see that now it becomes 8-bit label, and you have only 2 values, 0 and 1. That's why I call binary. Either background 0 or 1 as the material. Yes. Each pixel, no, each pixel is from 0 to 580. Yeah. It depends on your image, because here they don't have that intensity up to. Yeah. That's it. Yes, exactly. One range of threshold. But again. Yeah. 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 It's gonna be better tomorrow with the watershed segmentation for sure, because and also we have also like machine learning to detect different pattern of the object. So yeah, with this just very global one material segmentation. So everything that are in this blue mask gonna be considered as material one. So we have only one material, actually two or one as a background at 0 and material 1. And because of we have this share color map on bottom here, we have 8 color share color map. So we start counting material number at material 1. For example, here light blue is 1. If you have 2 material, the material number 2 going to be 2. And if you have 16-bit and you have like 1,000 of material, 8-bit color to be recycled. So if you change to 256, so the first material is hard to see, so you will not see it. So that's why I start with the 8-bit. And I can also visualize them with auto slide like this. And again, if you use probe tool here for click and update, again, arrow, probe and click for update. If I click here, shift click, you can see the value of 1. Anywhere you click is value of 1. This is the material 1. But if you click on the background, it values 0. So now it doesn't have any vary in terms of intensity because it's only binary image. It's either 0 or 1. Okay, and you can see there also binary color watch as well to overlay on top of each other. And next, what I will do is that how can you get rid of this border binary voxel? So we have module called border kill. So activate right click and then select border kill. So border kill. So this module will remove any voxel that are touching the bounding box. So I add bounding box quickly to the result like this. Here, so anything that are touching this bounding box will be removed. So let's say here, then go back to border kill, just interpretation of 3D and select maximum number of neighborhood and click apply, and then you get the results that look only like this. That's only here. You can also use color watch to visualize the result as well. So if I have auto slide on the first result binary image, and then I use second color watch here, add it, and then select on little white box here to get data attached to the result from border kill by data attached. Still, you don't see anything because the auto slide color map is still 1 to 8, and color watch color map is still 1 to 8. You have to change color map of the color watch to label 256, so that you see the difference. That before is in blue and the new result is only in purple. You can also change the transparency like this. Okay, this is how you remove the voxel that touch bounding box. So if you visualize them with voxelized rendering, is before you apply the border kill, and after apply border kill, just use the same volume rendering, you get only this. And I can also remove like this. So before everything that inside that thresholding, and then using border kill, you can remove this unnecessary voxel binary image. So at this point, you can see that I start to create workflow. So I tend to add data on one side and have this computing module and on the other side. So you can see step by step where it comes from. So I start with chocolate bar, I add median filter or filter sandbox in some case. If you cannot use the filter sandbox, and use median filter. You get the results, and I apply interactive thresholding. I get the result from threshold, apply border kill, and I get the result. So this result can be later batch processing called recipe. We can create the recipe from this workflow. And in each step, you can attach all the visualization, either 2D, 3D, to visualize them in each step. And you can also remove them like this. So at this point, what I'm going to do is that I would like to do some calculation to get those statistics like shape, size, distribution. But you see that they're still considered at one material. So how can you get the individual volume or surface area of each individual object here? What we need to do, we need to label them to have them into individual objects. So as you can see here now, we have only one material, 0 and 1, 0 background, and everything in the bubble in the blue mask here is called material 1. So we need to label them by add labeling 1L. So sometimes I'm surprising. So you can also start to interpret again to the 3D, and just by default use 3D maximum number of hood of 26. Then you get the result that already labeled, and this look like this. You can see that everything is labeled with this 8 color. Only it's like 1 to 8, and then when you use up all the color, it repeats this 8 color again until they finish all the material. And you can change to, for example, 26 label like this, and you can see that there are more color. As you can see now, no different materials. So just for example, you look on the border queue result, you have only material 0 and 1, that's one materials. And then when you look at this result from the labeling, you have about 613. That means we have total of 600 materials identified. So for example, you want to calculate the volume. If you don't do labeling, they calculate at this one volume for the blue material. They consider everything in this blue material as one material. You're going to get a very large volume of everything in some. But if you label them first and then you calculate the volume, so you will get this total individual volume for 613 objects or bubbles. Is that okay? So to calculate them, we have the module called label analysis. Label analysis. So type label analysis here, and this module is really really powerful as well. It looks very simple, but you can do a lot with this label analysis module. So at the property part of label analysis, you can look at the bottom here, measure. So by default, you have basic measurement, but you can also have like basic 2D, and I think you have standard shape analysis and weighted shape analysis. So for example, you look at the standard shape analysis. What does it mean with this all measure? So you click on this little 3 dot next to it. They will open this the measure group. So you can see that by default, we use basic measurement. And in basic measurement, you can see the measure that are included in this basic measurement, like volume 3D, area 3D, center of mass of X, Y, and Z, and the mean intensity. So this is native value, and by default, you cannot do anything with this. If you want to use this list but modify them, you can. So by click on this button here. This the third button called copy the measure group. So if you click here, they will copy all this measure that you have here, and then you can modify them by copy them first. Let's say basic 3 that I'm gonna modify them. I already have it. So basic 4. So they copy from the previous basic measurement, but now you can also modify or add. You can maybe I just remove this by click on the belly center of X, Y, Z because I don't need them, but I can add something else like geometry. I go to, let's say, equivalent diameter or orientation in pi and theta, or you can look at perimeter as well, symmetry. For example, you can add anything you want. Apart from that, you can also create your own measure as well. So we have this custom measure over here. By click on the custom measure, you can create a new measurement. So for example, I'm going to create, let's say, equivalent diameter divided by perimeter, let's say. So this is my measurement that I'm going to create myself. So you click equivalent diameter divided by perimeter, click OK. And then you need to put the expression, the logical mathematical expression or your equation. So I just select the geometry here, select equivalent diameter here, and then divided by. So before, when I have it only equivalent diameter, it's okay because it's green, it is valid. But then when you put divided by, it's still not complete, so it's not valid. So it turns to red. To complete the equation or complete the expression, I have to divide it by perimeter. This one. So now I have complete green again. Then can click close, and now this my new measure, equivalent diameter divided by diameter, available here. So you double click on it, and then you can add it into your measure. I also have this, for example, volume 3D divided by area 3D. You can add to the list as well that I created before, and then click OK. And now you have this measure that you just created yourself. So with some basic measurement list, and then the one you are created, custom created, and you click apply. So when you apply, you will get the Excel spreadsheet here that you can export, and you can, for example, look at the volume 3D here. You can sort it top and bottom, like from highest to lowest. You can also visualize them by attach this. Yeah, I think this is something doesn't come up. Usually, when you click on this, so you have the kind of distribution histogram plot, and you can work around it. You can also export this by click here as the, for example, spreadsheet or CSV file to work further. Let's say if I have this area 3D like this, and I want to filter my object here according to area. So you can do that by using, there are two ways. If you know the value from this label analysis, so you get this table value here. So I want to, let's say, select 3D on the header, and then you can sort ascending or descending as you like. You can see that from very low to very higher. So then what I will do, I use some parameter to make it cut off value, maybe somewhere in the middle, like here, this one. I want to use this value of the area 3D as a cut off value to filter further. So I go to this result here and right click and try analysis filter. Analysis filter. And with analysis filter, they automatically link to the label image as well, because they need the information from the real value together with the table here. So in analysis filter, you can see that in the filter, you have option of different parameters. So it depends on this value here: volume, area 3D, mean, equivalent diameter, and orientation, and so on. That's what you created. So as I mentioned, I want to use this area 3D as the cut-off criteria. So I select this area 3D over here, double click, and you can see that area 3D is appear as expression on the filter box here. You have this area 3D, and you can see that shows some kind of value, and you can select like in the mean value here. So as I mentioned, I would like to have this value as a cut-off value. So let's say I want these area 3D that are larger. Then maybe I want not so many objects. Okay, maybe I just select this value like here or here. Okay, let's say to have about 10. So I just select by Control-C, copy, and paste it here. Again, now before it was red, now it's complete because I copy this value here to complete my expression that area 3D larger than this value. Click apply. So now see the new result. I have only 15 objects. And the same, I can also visualize them with the same volume rendering. So this before the filter, and this one with after the filter. So because I used very high cut-off value, that area 3D larger than this value, so I get only this object left. This is what you can do with analysis filter if you want to specify what value to be cut off, to be removed, to be included. But if you don't want to be more like really specific, you can also do with not analysis filter, but you could do is with the module called filter by measure range. So again, go back to this result one.label or the label image, this one here. You can right click and add filter by measure range. Filter by measure range. It's similar to what you see in analysis filter that I did before. So here in the measure, you can select different type of filter. So for example, you go to volume 3D or elongation or anything that you would like to, and you can see the distribution, but I think it's not a good distribution in volume 3D. Maybe I go to equivalent diameter instead. Yes, so I select the measure at equivalent diameter, and you can see in the range here, the histogram range, so you can see a good distribution. So let's say if I remove a small equivalent diameter to half of them, at least I will have half of them filter out, and then you can use the same volume rendering to look at the volume. But it's not specific to certain value. It depends on, yeah, it's still specific, but you can not knowing it as one, like what is the value of each individual object. Is that okay so far with it? Pardon? Sure. Yeah, definitely. Yeah, we can make 10 minutes. Yes. Yeah, it just finished from the workflow, and we can come back and continue. Okay, let's start again. So at this step, so what you could do is to save the project. To save project, you can just go to File and Save Project. You can save or save as, but the same thing. So once you click Save, then you have two options. You can select to minimize project size, or you can minimize project computation. The difference that if you minimize project size, every time you open, next time you have to recalculate everything again. Gonna take so much time, but the size is smaller. But I recommend it to minimize project computation because the file size will be larger, but then you don't have to recalculate. Imagine if you have a few steps, it's okay, but if you have to run over again the calculation every time, it's gonna take so long time to open every time. So just make sure you minimize project computation and click OK, and then you select the folder where you want to save it, and they have two options to save the project. You can just save normal project called the HX project, or you can just save as pack and go. So this pack and go, it will include it or embedded the original data inside of the folder of the file as well. Imagine if you working on your computer and then you want to load this project to present on the other computer, or you want to share to your colleague. But when you save in normal project, then the Avizo try to look for the path in your computer, local computer, which is not there. That's why when you want to send the project to someone, or you want to have the project run faster, or even send the project to me, make sure to save it as project data pack and go, because in this case, then I can have the original in the file that I don't have to look for the original data in the local folder. Okay, so that's two options. So once you save the project, as you can see here at this step, we already create some kind of workflow. So we have a few steps coming up. The question is, how can we do this kind of batch processing to repeat this parameter workflow on the other dataset? So we can easily create this workflow, not include this visualization, of course. So just leave visualization. So this is the workflow that I created. You can create so-called a recipe or the batch file by select the output that you would like to create. So in this case, for example, I select maybe 3 output. So I want to select the label, and I want to select the result by click shift, and select the final result from the filter by measure range, by press shift, or you just use this drag to select your multi-output, or you can just select only one output as you like. So I just show you that you can select many output as much as possible. So I select 3 output, and I want to create a so-called recipe on this. So by right click on it, on any one of them that you selected, and then go to create recipe here, and then click create. Once you click create recipe on this selected output, they will jump to the recipe workroom. So I'm not sure if some of you that use Mac have this option, but I know it's not working or not support with Mac anymore with recipe workroom. So usually you will have this recipe workroom, and you can see that they have list of operation that we do. So we start from the chocolate bar, input image, and then we come to filter sandbox. We do module, or you can use median filter. And then you have interactive tracing, thresholding, border queue labeling, filter by measure range, and label analysis. So this is the list of measure that we did. So you think it's correct, then just click save. So I save this on desktop, let's say, easiest. Then select this multi-output recipe and save it. then I have this module, the recipe file saved. Now I want to apply the recipe that I just created on the new data supposedly. So the easiest way to close this project, you can press Control and N. This Control N is like you open a new project. When you press Control N, they will discard this project. If you want to save it, you can just save it or discard it. If I don't need to save it, I just click discard. So when you press Control N and click discard or save, and then you just remove everything. The same when you here to open data is Control O, or the new data, Control N. Yeah. So I will just load the new data set supposedly. That means the chocolate bar, you can easily go to Start and select again the chocolate bar.am. And now I'm going to run the recipe that I just created on this data set. So if you hover the mouse somewhere in the empty field in the project view, somewhere anywhere like this, and you right click, you have this option to create object. So again, right click somewhere in the empty space in the project view, right click and select create object. And then you select this, sorry, again, create object and select this recipe player here. Create. And now we have this recipe player coming up, the module. And first thing we do, we need to load the recipe here. So click on the three dots on the recipe properties. Then you can click and locate it, the file, which is I save on desktop here. And now the recipe file is saved or loaded on the recipe player. Now you have to input data. You can either do by put this string here and attach to the dataset is the chocolate bar, or you can just go to the property board and then on the input data, just select the dataset to attach. So I select chocolate bar to attach them here. And now before we do the execution, we have two options. You can either click apply or click export. So the difference is that if you click apply, you get only the final three results that you selected. So I show you quickly. So click apply. If you remember, I select to show the last three output in the table, the analysis table, and the label image, and the label image that's from the filter. So we get a table. And then the second one is this one before the filter. Yeah. And then the last one is the chocolate bar that filter out. This one, like this. And you can see that here you can easily run the same parameter. And you can always go back to the recipe workroom, and you can also change the parameter. For example, you want to change the threshold step. If I click here on the module interactive thresholding, and I click here to have a break on the step, and you click play recipe one more time. And then we stop for you at the interactive thresholding module. So yeah, so you can start to maybe change the threshold a bit more and then continue. And then you will get a new result that have different slight adjust on the new threshold, which should look like this one, for example. You will see that it's really flexible to adjust. And so this one, number 2. For example, you can see that the result is different because of you change something in the parameter during the step. And if you want to have the full workflow coming up, so instead of click apply, what you could do, you could just apply this export. So all the steps that have been done in the recipe will be exported. Okay. And that's all about the recipe and how you can generate a batch processing file. I think you might have question if you have maybe 100 or 1,000 of parameter, how can you run the batch processing on this 1,000 file? We have the scripting called apply recipe player. Let me connect to the extra library. So we have the open platform called extra library. I cannot open it anymore. Okay, anyway, this one, Actually, here you can load many of the scripting object, the recipe, the tutorial, many things that you can do with Avizo. So in here, I will load the script object called batch apply recipe player, which is in this folder that I already just show you quickly so you know that we have this option. So we have this script object. If I just open it directly, and what you need to do is in this script object, you can see that we need 3 input. So the first one, you need to load the recipe file. So I have the recipe here. The second one, I just select number of file to be processed. So I add it. I go to the data. So in this example, I have 4 files that I want to process. So I just select 4 of them. Imagine if you have 1,000 of them, you can do the same thing. So select 1,000 and it will run in the background. And then you just need to select output directory. Then it's on desktop. Yeah, so if I just create new folder and let's say results. So here, so you can see I have 4 files and 1 recipe, and then I just click apply, and then they will run the apply the recipe that we create in the background to get all the results. And yeah, it is 4 files. It's gonna take a little minute, but as you can see, I will show you here. I cannot find my desktop. Okay, I didn't select the right folder, but anyway, as you can see here, they start to generate the result with the batch, and each result will explain or show here as well. So in this, you can also run the recipe in no time to get my result. Okay, that's some example. So next, I will show you some how you can do multi-thresholding and some other thresholding as well. So let's go to open data. If you click here, open data, it should be on your drive C, and select program file and Amira Avizo. I think in this one, your install folder of the Avizo, and then go to data. Let's say select is pump back bracket motor. Pump back. So just select one pump bracket CT scan example. If you look volume rendering here, and you can see that because before I open the chocolate bar and the voxel size is different. So that's why when you open this, you cannot see anything. So the solution is just press this view all or press space bar button. It should come. So if you look on the histogram, you have like 2 curves from the dark and bright. So maybe it's not good example. I'm really sorry for this because I want to show you the multi-thresholding. So maybe this is not good example. And then I just to remove this because you see that have only 2 because the background and the bright one. So just Control N and remove everything and open. Let's say go to data. I think it's motor. So in data folder, go to tutorials folder and select motor somewhere here, motor.am. Again, the folder data, tutorials, and then select motor.am. And just take a look, maybe 2D with auto slice. And sometimes we have this occur that the visualization is not activated. You have to click one more time. And you can see that when I activate the auto slide, as I mentioned, because the focus size is different from previous. You open, you can see it's really small here. So you just press this button, view all, space. It should come back to the normal view. And you can see they have at least like 2 or 3 threshold here, here, here. So yeah, can easily use so-called multi-thresholding to threshold this object based on the intensity of each region. So I activate multi-thresholding. Multi-thresholding. With multi-thresholding, you can see that by region, by they have this exterior, it's like something outside, and then they have range one. So, and then when you have these two exterior and range one, they have only interface between the two range, so exterior and range one. But if you start to type by space and then maybe range two, like this, and then when you click somewhere, and you see the interface from the second range will appear. You can do the same thing, range 3, like this. Sorry, have to be in the same word, like this. You have the more. It doesn't have to be this word. You can put anything like 1, 2, 3, 4, 4, for example. And then you will get the 3 interface between range 1 and 2, 2 and 3, 3 and 4. So just to be sure that you have each range have the values. So I have 4 region and then 3 interface. So each interface you need to adjust the threshold. So here it's the same like you do with iterative thresholding for maybe 3 times, then you get this kind of 3 materials. So I adjust the range 1 about 35, range 2 maybe 100, and then range 3 maybe somewhere here 100, 200, 190. Yeah, you can also click apply, then you should get this result. Look at the auto slide like this. You can see 3 material not include background, and you can see here on the property port, and you look at the label image, and now we have more than 1 material. And by the color map you have here, we start from material 1 here, check column 1 to 8. So material 1 is light blue, and material 2 is darker blue, and material 3 is the red one. And yeah, I emphasize this because we're going to use this information, material number 1, 2, and 3, to separate object, and the background is 0, so it's no material. And again, if I look on volume rendering or voxelite rendering, this you will have this object here, but you don't see much because of the color is not much different. You can see the red, material 3, darker blue, material 2, and then light blue, material 1. You can also do it again with auto slide on the original data. I attach a new one, let's say auto M, attach auto slides. And if you have this problem persist, just click on this and then visualize them again. And then with auto slide, right click and add color watch. And on color watch, you can see that you have this little box again, select data and go to label. Then you overlay them with this color, or you can change from 8 color to 256 color, and you can send different color here. Okay. Now I want to show you something that is really useful. It's called multi-thresholding. Yes. No, because I just look at the value that I see on the histogram of the auto slide, so I cannot show you right now. If you look at the auto slides and without color watch, you can see that in the auto slide or in multi-thresholding, they have this kind of representative of the histogram here from the very low, and here and here. I just randomly select the region of interest. That so value from 0 to 35 will be the material 1, and from this to this will be the second material. So you have like early dim value and the brighter value and the brightest value of this. That's two. Yeah, but you can also define by, if you know exactly, or you can do like this and examine what is exactly value. So if you use this chip for content update, and again here, yeah, and you can see that this value is a bit doesn't come up. And chip and click. Yeah, you can see that the bright value is very 255, and the lower value is like this one, chip. about 130. So it's quite a difference. So you can see what exactly value you would like to use to do this multi-thresholding cutoff. Yeah, but I just estimated to give you an overview that how you can create the multi-materials. And since we have this multi-material here, so if you would like to have individual materials separated, how can we do this? So yes. Yeah, so it depends on your subjective that what is the intensity should be your materials, because in the example you can quite easily see that let's say over here. Could be, but in general you just look by eye and then you see the different, or you know from your background research that yeah, I know that some part are brighter than the other. It depends on the characteristic material, but it's not very precise if this value. It depends on how you would like to separate them accordingly. Yeah. 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 Exactly. For example, here, it depends on how you interpret them. So you can, some people can say that okay, this even these two material are the same two intensity but the same material. So you can instead of have more range, you just okay have a bigger range that cover both dimmer and brighter. Only the brighter material to be one material. So it's how you define it when you create this multi-thresholding. But usually, we don't use this multi-thresholding that much unless you know the specific value from your experiment that you want to have this cut off value by yourself. So you could use this. Mostly we use origin segmentation much more powerful and better than this multi-thresholding. But I just want to show you there's an option you can do this kind of easy multi-thresholding. And oh yeah, yeah, yeah. Exactly. So it's your judgment if you want to separate them according to what you see, or you want to have like your own reference to. For example, I shown you now on the interactive thresholding. It's same as you have interactive thresholding for 3 times. So first time you need to adjust like which threshold you are interested in. Like here, I want to have my first range, this one, and the second range I want to have it somewhere here, and the third range I adjust the range again somewhere here. So it depends on how you define your range. Yeah, you can see it's subjective to one user to define your range of threshold. So yeah, the idea is next is that now we create multi materials in one label field. So so far we understand that we have grayscale and we create so-called label image. And then here we have multi-material label image. And this multi-material label image, we call it label field. So in this label field, we have the field like a container. And this label field, they contain at least 3 materials. So light blue, darker blue, and the red one. So each material, they have the ID 0, 1, 1, 2, 3. So 0 is background. So now I want to extract individual ID of this object. So you could go to this result of the label image or label field here and attach arithmetic. So right click and select arithmetic. Yeah, arithmetic. So with arithmetic module, you can see that they have some options. You have many input A, B, and C. But so far we have only one input, so it's just motor label. But you can add more input later, and you can be really useful later. You want to do many operations using mathematical operation. For example, you want to do masking or you want to subtract images, so can do by using arithmetic. Many things can be done via arithmetic mode. So this is the very simple one to do with arithmetic to select a material. For example, I have only one input A, this one, motor the label as input A. And next thing is that result type. So I just want the result type of input A. And then result channel. So I want to have the result like input A because it's already a channel image, but you can change it and you can see what the difference if you change something. So the expression would be I have channel input A here, input A, and I want input A that only material 1 in input A. So this expression that I want material 1 from the input A equal 1, and I click apply. So I get the results only material 1, which is the light blue, like this. Which color watch? You can see that material 1 has been extracted. Okay, back again one more time. If you look at this image here, that's why I keep saying that when you look at the label image, you have 3 material, and material 1 is light blue, material 2 darker blue, and material 3 red one. And you can also use the same arithmetic. So I just pull the string here out, and I again go back to the same arithmetic, select A equal 2, apply, and I get result 2, and then visualize them, look like this. So to see the difference between 1, 2, and last one, I pull string from the result 2, and then go to the arithmetic and do the last one, A equal 3, like this. And then I get result here, which write them with auto slide with color wash. You can also look individually with box slide rendering, for example. Activate them. So maybe I remove auto slide. Yeah, so this result 1, material 1, result 2, more solid because been some part removed, and material 3, like this. So each material has been separated. And furthermore, you can also, for example, use arithmetic to mask this label image on top of grayscale. So if I have this grayscale model like this with volume rendering here, and I want to mask only the region that are overlapping with the label image. So let's say I reduce opacity of the volume rendering like this. So I want to extract the grayscale information that already masked on this blue material. So what you could do, you could add model.am, another arithmetics, and then you select input B by click on this white box here, input B, and then the result tree will be input B. And now I want to have the expression of masking is A times B, A times B. So I will mask this A, the original grayscale, by the B, result 3 here, and then click apply. So then I will get the results of the grayscale image that only have value of the material 3. So I just look at here. Yes. So this is grayscale image that's been masked. Before it was full grayscale volume, but after masking with the material 3 using the masking function on arithmetic, so we can create this mask. It's also something that could be interesting. Sometimes you want to create a search region of interest in masking. That's multi-thresholding, and we also have this auto-thresholding. So it's really simple. With auto-thresholding, you can just select what type of thresholding you want to have. For example, I do auto-thresholding on this example. Auto-thresholding, and you can see that you can select auto-threshold high, low, or 3 phases. So if you auto-threshold high, you will get everything that in their criteria. You cannot define, it's just decided by the software. So this is result from auto-threshold high, and you can also delete this info file here. So just a table, and then I visualize the auto-threshold high here. And if I look at the auto-threshold low, it should be for the background, like this. So if you threshold all the background, but it doesn't make sense, right? And we also have this auto-threshold 3 phases. So go to 3 phases, and then click apply. And then now I can just visualize them with auto slice and close the table. And now you can see this. So with auto threshold 3 phases, they will count the background as phase 0 as well. So you have background and 2 materials. So that's 3 phases between background and material 1, light blue, and from the light blue to darker blue, material 2 and 3. So 3 material and 2 phases. 3 phases of the 3 material. That's okay so far, like this. Okay. There are a few more to be done in terms of like this. What we're doing so far, what we create here is called automatic thresholding. Automatic segmentation. So everything can be done using all the modules. So you apply the module, you get the final result. This is automatic, and everything that have this automatic module that you apply here can be created as a batch processing file as recipe. So this is why we call it automatic segmentation. So we're gonna do some more operation to get some more understanding of Avizo software. So Control N to remove this and discard. Control N, discard. So what we do now, I'm gonna load the data chocolate bar. Go to let's start and then select chocolate bar.am. Volume rendering. If you remember, if I do quickly interactive thresholding like this to extract only the porosity. So I will use the interactive thresholding in 3D and click spacebar 1 here to bring up. So I don't need volume rendering. So I still have the auto sliding because of the software didn't restart properly. Yeah, so for example, if I want to threshold 3D of the porosity only, like this, you will have to do a few steps like thresholding, and you can see the effect of my graphic card working maybe too much and start to don't display properly. For example, here, and when you want to do this thresholding, it's not possible to really get only the air bubble because you always get some kind of artifact because of the same intensity. If you look onto the 2D, it's always like this. Even you want to threshold the air bubble, you can see that these interface here, they have the same intensity. That's why you always pick up something similar to what you have. So let me explain another function. First, we do median filter to smoothen them a bit. Median filter. Apply. And then use interactive thresholding. And try to maybe threshold only the air bubbles like we did before, like this. And then after that, apply the border kill. Because I threshold the wrong one, so I have to threshold the filter, not the air bubble, not the original one. So I threshold the air bubble like this. Let's say, okay. Apply, and after this step, I will do border kill. Again. So I will come to this step like we did before, like this. Yeah. So that's how we get only the air bubbles. So one interesting thing to show you here, it's called closing, opening, dilation, erosion of the label image. So what we see here is the label or label image or binary image. So we can do some more operation. For example, you want to dilate them. So what I will do now, I'll just use, let's say, color watch to visualize this data from original data and add color watch from original data to the final result like this. So, okay, maybe the first thing to do is, let's say, erosion. Right click and select erosion. Which erosion attached? So yeah, that's an implication. We will erode this object by number of pixels. Let's say I want to erode them in 3D. So that means ball like this. So I select ball type. That means I will erode them in 3D direction by 1 pixels. So everything in 1 pixel will be eroded. If every label image here will be eroded by 1 pixel. So I click apply, and then I move the color watch overlay to the new result. You can see that it's been eroded a lot. Okay. And after I erode apply erosion for 1 pixel, I can dilate it back. So I will add the module called dilation. Dilation, because I erode by 4 and 1 pixel, I do the same. I dilate it back by ball and 1 pixels. Then I will get my object like this. So from original data, you have this one. Oh, sorry, this one. And then after you apply erosion, followed by dilation, you will get these results here. So these two operations together we call opening, because you see before it was like this, and then we kind of open or breaking them apart. So we call this opening operation. So to make it easier to see, just add volume rendering here after the border Q. So this is images before apply erosion, and when you apply erosion, you get most of the object that are really thin will be eroded, and only whatever left the voxel side of the level image will be dilated back. So that means all the object that already been eroded cannot bring it back. Only the last object that still left will be bring back by dilation like this. So after you apply dilation, you get this object here. So I overlay them before using volume rendering with different color. Let's say 256. Yeah, as you can see it. So before it's in purple, that before the erosion followed by dilation, and after we get only the blue object, and this is called opening operation. So yes. Yes, for example, you have the trabecular bone that has network stuff here, and you want to separate them, but it's really difficult to. Okay, I'll show this example very easier if you understand it. So if you look at the data set, it's a trabecular bone, and so the reason that they want to break the bone, and their aim is to break them, to separate them from each other based on the thinness point of the bone structures. And to do that, it's not easy way to do that. So there's no defined criteria. So what we do is we add the same. Show you quickly. So I will do, let's say, first I threshold only the bright area of the trabecular bone, do interactive thresholding, like this. And threshold them. So I only threshold maybe only the right object like this one. And now, yeah, the next step is how we break them based on the thinning point. So we want to break them, and the operation is called opening. So we want to open the thin part, and it depends on number of pixels. You can see that the thicker part is more like larger pixel, and the thin part is have less pixel in terms of length dynamic. So if I do again erosion followed by dilation, so I do erosion maybe let's say cube, because ball is too much, cube by 1 pixel like this, and followed by, okay, let's say the result is cube. So before here, and then I loaded it, it's been thinning, or maybe more, maybe 3. Yeah, so you can see that before it was like this, and then I try to break apart on the thinning point. So like you see this point, it's thin, it's been breaking, but we want to get the same result. So we just want to bring it back. For example, I dilate back of the object. So use cube and use the same 3, apply it. So and I get the object back like this. But yeah, so if you look on the original data before breaking, so I have this something like this. And after you do erosion, it's like the thinning on the very thinning point, only the thick part left, and then you just dilate it back. So this kind of opening. So maybe I should do ball to make it clear effect. So ball maybe 2, just to see. Maybe 3. Yeah. So it's strange. Erosion ball by 3, and then dilate it back. Oh yes, because if you look here before it was very thick, and then you break apart 3 or maybe more. So let's say, sorry, it's for this. Yeah. So you can see that when I eroded a lot, some part it's already breaking, or maybe even 7. Yeah, like this. Okay, most of part are breaking, and then I want to just bring back whatever left here by dilate it back. So it should be ball and 7, same dimension. And this, you can see that before we have object like this here, and then we just break them, and then whatever we break, we get different part, separate them at the thinning point. And I show you this because they have some options. You can do erosion and dilation, and all of them in combination is called opening. So instead of using erosion and dilation, you can also easily do so-called opening. So I go here and I do, let's say, volume rendering, and then I do opening. This opening is exactly the same that you apply first erosion by ball about 7 pixels, and then you also reapply the dilation back by about 3 pixels. So you get the same result of the opening. And in the reverse way, if you start with dilation first, and then you follow by the erosion, then it becomes closing. And then you have this closing mode. It will be really useful for some structure, like you want to do some close the pore, or you connect some thinning point. It's the same way. So if I do ball, maybe 7. So this closing look like this before closing, and after closing you should get something, but not much. Yeah. So now you see that you can do dilation and erosion. It depends on the sequence. If you dilation first, followed by the erosion, then you get closing. But if you do erosion first, followed by dilation, you get opening. And why we have these two identical things? Because sometimes you don't want to have the symmetric closing or opening. You want to open more than you want to erode more than dilate it back, or you want to dilate more than the erosion. So you can have 2 options to use. You have symmetric closing or opening, or you can do this dilation erosion in sequence. Okay, and this also we come to another example of interactive top hat. So go back to chocolate bar. Yes. So in chocolate bar, if you look again on the auto slide like this here. Yeah, I have to press this. What we do is that we want to do closing of the grayscale image. So I apply closing. So just use the default cube and 3. After you close this image, you will see like this. And after that, I will subtract this closing image by original image. After subtraction, I should get so-called a top hat image. So I attach subtraction, or you can use arithmetic. So I can do first subtract image. In subtract image, you just select input image 2. So we have the closing image as input 1, A, and input image 2 is the original one. So I subtract them. I click line, and this will be the top hat image. And now you can see that you have the little pore here. That could be easier to segment using, for example, interactive thresholding. with interactive thresholding, this time I just do, let's say, 2D threshold. Yeah, so just select patch like this. You can see that I already threshold this object and click apply, and then I should get the results of air bubbles like this. So that you don't have to do border queue, you just use iterative top hat thresholding. And before we go to top hat, I just go back to this subtract image once again. Because we use subtract image, you get this result. So instead of use subtract image, you can also use arithmetic, the same thing. You attach arithmetic to the closing image. And with arithmetic, so you can just select input B to the original chocolate bar, and then the expression would be A minus B. It's exactly the same like we do exact subtract image, so you get the same results like this. Okay, so this operation of closing of the grayscale image and followed by subtract to original data. From this one closing, subtract by original data, you will get so-called top hat image. And this top hat image, you just easily to use the interactive thresholding. So instead of do all this workflow, we have the module called interactive top hat. So right click and select interactive top hat. Sorry, interactive top hat. Which interactive top hat? So you need to select what type of top hat. So because we're looking for the black feature of the porosity, so we select black top hat, and that's it. And then click next. So this time they're going to generate, you see the top hat image that using closing operation followed by the subtraction of the original image. So you can also select to see top hash image here. This is the original image. You can also select to see top hat image I will see before, and then you just adjust intensity range of the interactive thresholding, how you want to threshold your bubbles, something like maybe here, and then click apply, finish. You get the final results exactly the same like we do that operation. I just want to show you how this interactive top hat principle. So closing operation, and then subtract this closing image with original image, and you get top hat image. And from the top hat image, you apply interactive thresholding onto it, and you get this result like this. And it's, here it can be easy to delete. So now it's good example, because when you come to this point, you might ask, how can you get rid of this object here? So we have another module called volume edit, and this will come to the point where we should focus on the perspective and the orthographic view like this. So with this result here, I will add let's say bounding box here. And then the next thing we will do is we want to use the new module called volume edit. So go right click and select volume edit. So when you apply volume edit, I mean attach volume edit to the dataset, they already automatically show the dataset, the results here. So in volume edit, you can select different type of thing to do. For example, by default, there are two that draw here. So you can easily draw and cut everything you don't want. For example, I want to cut this part here like this. And I can just, let's say, cut everything inside. So I select cut inside here, cut inside, and you just position your cursor mark. That's why mouse is very important, and you draw around it. And then if you visualize the results, everything will be cut according, so it projects to the image. Okay, I show one more time. I just reset it, undo, you get this volume here. And that's why it's important to have the orthographic view, because you have perspective. You don't know is it you align it very precisely, so you should do it like this. Then you can see it easier that everything is overlapping, and then you can easily cut them. Or if you don't want to draw, you can also use different tools like tab box. And here is it can good example to see how important to have orthographic view, because if you are on the perspective view like this, and you want to use this tab box to remove this thing here, but you don't know if you really position your object in the right way. You might see it like this, and then I think, okay, this way it already cover everything. So here you click cut outside, for example. And then if you look into perspective, in the orthographic, maybe it's not correct way, like this. So it's better to do volume edit with the orthographic view. Okay, maybe instead of this result, we go to the full volume and then work on it easily, like this. Go to chocolate bar from the beginning, and you can add volume rendering to chocolate bar like this. So let's try first with the perspective view, and we add volume edit. So right click volume edit, or just activate it from the side if you already did it. Volume edit. Which volume edit? Yeah, so it comes automatically with the result, so you can maybe look at the result right away. So we already see that you can do drawing. So if I want to cut just inside, and I try, for example, if we are on the perspective, I think I try to draw something that puts all the edge like this. Oh, sorry, my mouse is not. And then you see it cut everything. But if you look on the orthographic, it's actually is over the edge because of the perspective full view. So I undo. And instead of draw, because you do tab box, and I can use different tools. For example, I use cylinder. And in cylinder, you can change different axes. So you can use Z axis to cut it here, or you want to use Y axis to cut in this way. And again, if I go to, let's say now that it's a good example about the orthographic and the perspective view. So for example, now I want to have the cylinder that has all full border on this side here by using the way you look at the orthographic view, perspective view. So for example, I think I touch the border here, and again here, and here, another one here. So in perspective, it looked like it touched, but in reality, if you go back to orthographic, it's already too much because the way it's project perspectively. So that's why it is important to use volume edit with the orthographic view. If, for example, if you have this criteria that I want to cut until the border of my material, so you have to reorient it in this way, because the way it cut, it will project directly, like camera projection, project right onto your object. So for example, here. And then if you want to cut inside, and then you see thing here. Is that okay so far with the volume edit? And you also have different tools. For example, you can go to ellipsoid as well and undo, and then you just select ellipsoid by here, and you can change that position. So cut aside, for example, and you get everything only in the ellipsoid shape. So they have different tools, some shape, draw, box, cone, ellipsoid, triangle. Yeah, that's one thing. Yeah, when talking about volume edit, we also should think about something similar. It's called extract subvolume. So volume edit, you just like manually select region of interest, or you want to, for example, clip this thing here. So using volume edit easily with drawing. But if you want to maybe extract small subvolume, later when you want to do deep learning, for example, you want to extract exactly more precise subvolume. So I'm going to do that to show you right now. We open another data chocolate bar too. So this one I change color map to any color like this. So we have one chocolate bar, and the one is grayscale like this. So if I want to cut exactly the same region of interest, you have to start with extract subvolume. Right click, extract subvolume. Here, extract subvolume, and you can see this subvolume is coming. So by default, you can do max width, max height, and max depth like this, so you can get everything. And then let's say if you want to get half of the position on every direction, like this way. And then just maybe draw here half of this subvolume. And you can see that this information about the size of the bounding box of this extract subvolume. So let's say I do this value here and I click extract subvolume and then click apply. So now I get the result from, let's say, chocolate bar A and use this volume rendering. So I get like this. And now I want to do the extract subvolume for the chocolate bar. I thought that if we have this coordinate here already, so we can maybe directly use the coordinate that we have here to the new chocolate bar. So you will see what happened when I move to the new chocolate bar. The coordinate is reset. And if you don't remember what this coordinate that you have it here, you're in trouble because you don't remember it because it's been reset to sync. So you have to try to move it back and then to see it precisely. That's not easy way, but there are really easy way to do that. Instead of we have to add the reference about region of interest ROI box. So to do that, I will just add right click and select ROI box. ROI box here. And with this ROI box, so let's say I go to the full volume first, and then you just define what you see on your ROI box. Again, I do the same thing here. And this ROI box will be fixed to this value that you set. And then I will start to do extract subvolume on each of the chocolate bars. So chocolate bar 1, extract subvolume. And how I can link this coordinate of the ROI box to extract subvolume. So in front of the extract subvolume little white box here, click on it. You can see it ROI. So you can link the ROI to the ROI box, and then click extract apply for extract subvolume. And now you can see volume 2 like this. The same for now I deactivate the first one. The same for the chocolate bar 2. So I want to extract exactly the same subvolume. Again, extract subvolume 2. And then link the ROI to the ROI box. Then you get the same ROI box, and then you click extract subvolume 2. Then you will get exactly the same subvolume 2 in the ROI box, like this. So either way, you get exactly precisely the same dimension of the object to be extracted. It can also be used for visualization as well. You don't have to do extract subvolume at all. So for example, if you want to visualize this chocolate bar here, and you want to visualize only the ROI box here, you just click on the bottom part, and the top part. You can see that they have this ROI as well. All right, and you link the ROI to the ROI box, and you will get the visualization of the region. It says okay. It makes sense with this. Any questions so far at this point? To make sure, yeah, because the time here is still European time. Okay, we are almost ready, and there are some part that could be interesting. It would be interesting for you too. So to create surface, go back to chocolate bar, the famous one, and I will do really easy automatic thresholding, auto thresholding, and just auto threshold high and click apply. So what you get here, label image of the chocolate bar, and remove this table. And if you look at the volume rating of the result chocolate bar from automatic thresholding, you get like the full volume with some porosity. Anyway, but the aim here, we're gonna create surface. For example, you want to do 3D printing, so you can generate 6 surface, triangular surface, and then you can export this surface at STL file, OBJ file for 3D printing. For example, you want to maybe 3D printing the coral or some bone, skull, tooth, or anything, or even some material science part, like some proteins that you want to put into the materials, the biomaterials. So we have the label image, only one materials. So to convert to surface, really easy. You can do generate surface. Generate surface. And then here you just use default parameter, but you can see the smoothing extents. I'll show you later. So I use the default 5 and I get the surface. But for the surface, we have to view them with different module called surface view. So I'll remove volume rendering for a while. And this result surface here, you can right click and select this one, surface view. Double click, and then surface will come up here. And this really is a surface because it's created by a calculation of the surface. And if you zoom in, you can see that there actually whole surface, nothing inside. I cannot zoom in yet because of my mouse. One more. Yeah, you can see inside there's nothing. Or if you just add clipping plane, the easiest way. With clipping plane attached and clip them. Here you can see that actually inside is just an empty surface. Everything you see is a triangular surface. In the surface view, you can do, for example, now it's by default it's shaded draw style. You can change to, for example, iron line. And you can see what I said about the triangulation. So this is composed of 2D triangle surface. Also for the bubbles. Yes. I cannot hear. Yes. You mean like stitching in 2D, right? Yeah. Yeah. Okay. Now I think it's that kind of satellite image that you mentioned. I am not certain. Yeah, I think we didn't have this application yet. So I'm not certain, but I will come back to you. So we can discuss this later. Yeah, because I am not aware of this. It might be possibility, but I haven't tried yet. And back to surface. So I remove clipping plane to see the surface. So you can see that visualization you can do like shaded and outline shaded, or you can go to transparent and maybe change color. For example, like something like this, and you can see set transparency as well. Transparent. Yeah, and also remember that I said that during the generate surface we could define the smoothness of your surface. So by default, it's fine. If you extend the smoothing extend, the more smooth it will be, but also you reduce the quality of the surface. You can see that, and you go to max, like here, it's very smooth. But if you go back to like maybe 1, there will be some warning. They're gonna create so much triangulated surface. But yeah, more. So it depends on how you like to smooth them. And after this, you can export them. So you click on it and you can see this X option to export. And then you can just select, for example, you want to print them. You can select the STL file. Sorry. And we can also select, for example, OBJ. Where is it? Wavefront OBJ. So this for 3D printing. Imagine you want to segment certain part and print them for 3D printing. So that's possible with the surface. Okay. That what we see so far is also still automatic segmentation, and we use mostly project view because it's really, when you get to this principle, it's really flexible. You can add, remove, and modify your workflow. You can come back and then reapply it anytime. So it's really convenient. But we also have another workflow that quite easy, called like guided linear workflow, that could be maybe good for the beginner to start with and to have some idea. And also imagine if you have this volume like this, 3D volume, very large. So instead of apply all the parameter and execute it and to see if the result come up not what you expected, imagine you have like maybe 10 GB data set of the CT data with that, and when you click run even non-local bin filter, it's gonna take forever, and then at the end you don't get a good result and you waste a lot of time. So that's why we come to this new workroom called Image Recipe Designer. Here, what we do is that we just only extract a few slides, maybe 3 slides max. So imagine you have like 1,000 slides, you can select only 3 in the middle or somewhere that you interest. Only 3 slides is really small, and then verify in terms of quick preview, so you can apply any parameter and you see what the result coming next. So I'm going to show you right now. So you load the data, for example, chocolate bar or anything, and then you go to the image recipe designer here. Just click on the new workroom. As you can see here, this is an interface of the image recipe designer workroom. It's similar to what we did with the create recipe, but it's slightly different. So on the left, we have top left, we have module browser. So you can browse for any module. For example, I want to do thresholding or median filter. You can also browse here like this. Yeah, but we don't have the filter sandbox because it's a toolbox. So you have to really like individual filter. And on the bottom here, we have property. For example, if you activate any module, the property port will show here. And in the middle, we have 2 panels. So step input and step output. And on the right, we have recipe, where you're going to create your workflow or recipe. And we need to load the data so far on the bottom right here. So just select the data to start working on it. We have only one data, chocolate bar. Just click on it. And the chocolate bar is being loaded. And you can see on the right, the recipe here, we have total of 100 or maybe 300 slides. Actually, 147. I load one more time the chocolate bar. I think I have some issue with my visualization. Okay, I need to restart one more time. And if there are any question in between, don't hesitate. Yeah. Do you know when exactly do we have to finish? Or do you know what time we need to finish? Okay, just let me know when. Yes,
it's okay. I mean, you can finish early if that's.
No. I mean, like I still have a lot to talk, but I will just finish.
But maximum is maximum is 5.
After this, I just finished because I think it's almost 5 already. So after this, image recipe designer will be really short, and then I'll be finished.
Quick question. So this image recipe designer, is that a new feature in 22?
Exactly. Yeah.
Okay.
Yeah, it's the latest version. It used to be the image volume processing, but now they call it image recipe designer. Yeah.
All right.
So what we do is we just open data, the chocolate bar, or just go to start the previous open. And then go to image recipe designer. Again, I load the data. And this new feature that you see that we have total of 147. And I position my slide in the middle. So you can select where you want to work with. So I just put in the middle here. And you can see you select number of the slide to be working with. So they start with 3 because the representative of 3D volume. So yeah, or you can select like 5 as well if you have not so big data, but 3 is good enough to get 3D representation. And in this new recipe designer, you can see you can also adjust the dynamic range of your data as well. Here, here. And also zoom in, zoom out really quickly, really easily. So it depends on how you adjust your dynamic range and the way you interact with. So step input, you can change to workflow recipe input and output, but step input and output is the most makes sense. So yeah, so as you might already have some familiarity of the workflow. So first thing we do, I want to add filter. Of course, median filter is good and very quick. And even you can try non-local mean filter on this step if you think it's going to be 5 steps. So for example, instead of running non-local means on the full volume, you can try on this recipe designer because it's going to be much faster. So it's non-local mean filters like this. And you can see that it's pretty quick. You can already see the result. Okay, so I delete it. I don't need median filter. So what I told you before, you can run non-local mean filter and followed by unsharp masking would be good. So this I will just start with the non-local mean filter. So I have to delete this step because I was too fast. So you can see that. So I have the reference step on the left and apply non-local means filter. You can see that, right? And if you want further, you can add, for example, unsharp masking. And then you can see that the result from non-local mean followed by unsharp masking is even better. And then you come to thresholding step. So you can threshold, you see here on the property port of the thresholding, you can adjust, for example, threshold. Let's say I'll do the same thing, threshold only the air bubbles and the background. And next step would be border queue. Like this. And maybe too much. XY plane, yeah, because it was in 3D, so everything is interconnected, it's been removed. So I have to just select only the in XY, otherwise it will remove everything. So you can see that now. Next thing is labeling. And finally, label analysis. Like this. Label analysis. And if I delete this, so you can see that I have final result very quickly. And you can just select which output to be exported. So I want to have the analysis label analysis here, the table, and together with the labeling, this one here. So you click these two output to be deleted, to be exported. But to make it faster, so I remove this non-local mean because you're gonna run in the full data set, it's gonna take a little while. So I remove this non-local mean. So I get something like this. Doesn't look pretty, but just show you the principle. Now we create a workflow called recipe. Just need to save the recipe somewhere. So I can save it on desktop, call recipe HXISP. So save it. So we're ready to run this in the full volume later. So you go back to project workroom, right click on the chocolate bar and select email recipe player and create it. And this email recipe player will link directly to the data chocolate bar, and you just select the recipe that you created. Set on desktop, this one, that HXISP, image stack processing. Open it. And now you can click apply to execute all the workflow you created on this data by click apply. You can see that they do some processing image using the same workflow that you create on that workroom onto this full data set. And now you get the data, the table on the right, and you can get the label image that you can visualize with volume rendering. And here I miss. Yep. So it doesn't make sense because I use the unsharp masking, not medium filter, but just to show you that it's really easy, more give you like step by step to see input output. You start with reference image and apply unsharp masking, thresholding, border queue, labeling, and label analysis, and that's it. And you just save it, and then just create one recipe, and you have multi images that have to run the same thing. You can just use this to run the email recipe player for back processing. That would be all for now. So yeah, tomorrow we will start on another segmentation workloop and separation object with watershed segmentation and so on, and also a new feature in the segmentation workloop. It's gonna be a lot too, and it would be nice if you could bring some mouse. I think it'd be easier for you to to manipulate the software, because with our mouse it's very difficult. So you have any questions? Or you can come back tomorrow with the questions. You can answer them, or you bring your data as well if you have a specific question that you can answer.